This is the video demo for assignment 2 of Cybersecurity in Computing course. Today, I will present my programming-based security project focusing on defending against critical cybersecurity threats in the e-commerce industry. This project analyzes common vulnerabilities like SQL injection, cross-site scripting, man-in-the-middle attacks, and abuse-related risk, and demonstrate how my Python program is designed to mitigate them effectively. Let's begin with the overview of the problem. E-commerce platforms are prime targets for cybercriminals due to sensitive data and the financial transactions that they have to manage. SQL injections, for instance, allow attackers to manipulate database queries to access private customer data. Similarly, cross-site scripting attacks exploit input validation weaknesses to inject malicious scripts, often leading to credential thefts or session hijacking. Man-in-the-middle attacks also target unsecured communication channels, intercepting sensitive data like login credentials and payment information. And finally, abuse-related risks such as brute force attacks exploit authentication weaknesses, potentially leading to account takeover for payment frauds. To get more information on these, please look at the report. So now we'll go into the code, and to understand how it works, we'll have to go through the libraries that is used in this program first. First of all, I use Flask. It serves as a web framework, enabling routing and server-side logic for applications. Flask WTF is also utilized for form validation, ensuring that users' input adheres to the predefined rules. The markup state library is also used to provide the escape function, which protects against cross-site scripting by sanitizing user input before rendering it to the template. SQLite will be used as the database system to store user data in this project, with parameterized queries preventing SQL injections. Flask Talisman is incorporated to add critical security headers, such as CSP or content security policy, X content type options, and X cross-site scripting protection, defending against a range of attacks. Lastly, I also use Flask Limiter to employ rate limiting, which mitigates brute force and abuse-related risk. And finally, I use here the request library in order to secure HTTPS requests, ensuring SSL validation to reduce man-in-the-middle vulnerabilities. These libraries will form the backbone of the program's security features. Now we'll go into the program. Let's move into the code, okay? First, we'll examine the program's SQL injection defenses. Like here, when a new user is added, they will have to the details will have to be processed using parameterized queries. For example, here in the add user route, as you can see here, the cursor, you will see the cursor execute, insert into user, name, email. This ensures that any malicious SQL input is treated as data rather than executable code. Similarly, the search functionality users, like right here, uses secure placeholder to prevent SQL injections during database queries. Next, I'll demonstrate the program's defenses against cross-site scripting. As I mentioned above, the escape function sanitizes user input, neutralizing harmful script before rendering them in the browser. As you can see here, you can see name, escape, form, name data, as well as for the email. Additionally, Flask Talisman enforces a CSP, restricting the execution of scripts to trusted source. This ensures that even if malicious scripts are injected by bypassing these defenses, they cannot execute. And for man-in-the-middle attack, program enforces SSL certificate validation when fetching external URLs through fetch secure route. Here's the fetch secure route. So if the URL does not use its HTTPS or if the SSL certificate is invalid, the request is rejected, as you can see here. However, I couldn't implement the SSL certificate because I don't have one. So this is just based to use as a demo, so for it to be implemented in the future if I had an SSL certificate. And lastly, I also implement rate limiting, as I mentioned from the library. As you can see here, limiter limit to 5 per minute. And for the add user route, we can add 10 per minute. This is used to prevent automated attacks like brute force attempts from overwhelming the system. So that is all for the code. So now I will implement it in a live server. As you can see, I've already started the live server. Now I'll move to Google Chrome. For example, in here, add user, I can add a name. I already have this Pham. For example, I will add an email, for example, user1@gmail.com. So for this, it is valid. So when I press add user, the user is added successfully. But for example, if I add something like Pham, and I still use that email, for example, user1 with here, it will say email already exists, enforcing the integrity of the database. So for that, now we move to search. I'll go to Pham, right? So when I search it up, we can find here Pham username. I also have one Pham who uses the mail that I just added, and another one that I added beforehand. So what about the rate limiting that I talked about? So here, I'll ask Pham this for the second time, the third time, and the fifth time. Wait, my bad. Here, and for the sixth time, I think, they will say there's too many requests. This will ensure that the website is secure against brute force attacks, as they cannot flood the system with too many requests. And lastly, here, wait, for fetch secure, for example, here I already have a website that doesn't have HTTPS. When I press it and I fetch it, it will say invalid or insecure URL. So it will only allow the website to fetch HTTPS because it's secure. So here I have HTTPS for OWASP. I use this for the report. So here I can fetch it. So I didn't format this, but this means that the website has been able to fetch the data from the website. Lastly, I want to show you this. So here I will go back to the terminal. I will turn off the program and rerun it. Here, I will open it. It is open. Now I want to show you the search user. Okay. So for example, if I want to inject for cross-site scripting, I use this malicious code and I put it in. As you can see here, on here you can see it is transformed into text form and not executable code, so the website is secure. So that is it. So this program basically demonstrate a comprehensive approach to mitigating common cybersecurity threats in e-commerce platforms, while it kind of address SQL injection, cross-site scripting, man-in-the-middle attack, and abuse. It leaves more room for improvements such as a more robust security design, as well as, for example, SSL certificate. So these refinements would further strengthen the program's defenses and ensure a secure user experience. That is all for my presentation demo, and thank you for listening. Have a nice day.